This is a lesson on multiplying and dividing fractions. So in each of these problems, you can see that they have a mixed number. If it's not a mixed number, it's actually an easier problem to work with, because the first step that we're going to do is to convert the mixed numbers to improper fraction. So in order to do that, we're going to multiply the 4 here, the whole part, times the denominator. So 4 times 7 is 28. And we're going to add the numerator to that. And that's my new numerator. So that'll be 31. And we're going to keep the original denominator. So 4 and 3/7 is the same as 31/7. On the second number, again, we're going to multiply these two. 2 times 5. We're going to ignore the negative for this. So just 2 times the 5, which is 10. We're going to add the numerator, which is 4, and that gives us 14. And we're going to keep the denominator of 5. We're going to make that whole fraction negative, which can go either in the top or the bottom. I like the top, it's fine. Once we get here, we have an improper fraction times an improper fraction. Ideally, we can look to see if anything is going to reduce. So this does not reduce, and this does not reduce. However, we can also try to cross-reduce. 31 is prime, and therefore 5 does not reduce the 31. However, hopefully you can recognize that 14 and 7 are both divisible by 7. So one way to show that is to substitute. I'm going to substitute. 7 is 7 times 1, and you might think that's a little bit foolish, but when you see what I do for the 14, which is 7 times 2, you can see that the 7 shows up. Again, all I'm doing is I'm replacing the 7 with something equivalent, which is 7 times 1. I'm replacing the 14 with something equivalent, which is 7 times 2. Since we have division of 7 by 7, this 7 and this 7 cancel each other out, therefore just reducing. A shortcut to do this is just to divide each of these numbers by 7 and replace the values. So on the first, we have 31 over 1. And on the second, we have the negative stays, the 2 stays, and the 5 stays. Once we get to the reduced version of the multiplication, we're going to multiply across. So it's 31 times 2, which is 62. And 1 times 5, which is 5. And since this was a negative, there's only one negative, the whole thing is negative. It can go on the top, it can go on the bottom, or it can go right in front of the line. And that's my final answer. I don't want to convert that to a mixed number in case I have other problems that I need to use that use that in a calculation with. Okay, I leave it as 62 over 5. If you want to call that whatever mixed number that is, I think it's 12 and 2/5, or its decimal equivalent, negative 12.4. You can do that, they're all equivalent, but for me, that's the answer that I'm looking for. On a division problem, what we're looking for, first we need to get the improper fractions. So again, we're going to multiply the 12 and the 3, that's 36. We're going to add 1, that's my new numerator, 37. I'm going to keep the denominator of 3. Keep the division for now. On the second number, we're going to take the 4 times the 7, that's 28. We're going to add 6 to that, that's 34. And the denominator is 7. We're going to take this could be pretty ugly looking. We're going to keep the original first number. We're going to switch the division to a multiplication, and we're going to take the reciprocal of my second number. Once here, okay, it becomes just like the previous problem. I'm looking to see if there's anything that cross-reduces. Now, 37 is prime, and therefore 34 and 37 won't cross-reduce, and 3 doesn't go into 7, So nothing is going to cross reduce, so I'm forced to multiply 37 by 7 and 3 times 34. 37 by 7, my trick would be 30 plus 7, each times 7. So 30 is 210, there's 49, so it's 259 over 3 times 34, again, 34 is 30 plus 4, times 3 is 90, plus 12, which would be 102, and I know that is reduced. And that's it for multiplying and dividing fractions.